Yeah.
Okay, so let's start. Thank you so much, Mahmoud. It's great to be here with you all to present this share task, which is the third or the fourth edition that we're running at FOSHA. And it's called the Financial Document Structure Extraction, meaning its goal is to advance the state of the art of document parsing, and we focus on PDF documents and trying to extract structure, meaning layout structure, from specifically financial documents. So this share task this year has been organized by the people whose names you can see on the screen. Myself and Juyon, we're both chief scientists at FOSHA. Abderrahim Aitazi is a data scientist. Sandra and May are both data analysts, and Mahmoud Hajj is from Lancaster University. So the goal of FinTOC 2021 share task is to simulate research about structure extraction from financial documents. One of the ways to extract structure from document is to calculate its table of content. So the table of content generally gives you a high-level overview of a document's content by listing the main headlines or the main headings that organize this document and how it's structured. So it has two main goals. It allows the reader to better navigate a document and also to narrow down the area to focus on where it's most likely to find a particular information the reader is interested about. And this applies both to humans and also to information extraction algorithms. So it's a very table of content is a very useful way to navigate a document, and this is why this task has been going on for so long. And it's so we've traditionally divided into two subtasks. One is to detect all the titles in the document, and the other is to organize them hierarchically. In terms of previous work, to extract a table of content, it was initially fueled by work on the ICDAR conferences, and initially previous work took advantage of the actual table of content. We will call them TOC pages that were actually printed in documents, and attempts were made to parse them in order to identify the structure of that document. But obviously, not all documents contain TOC pages. And what if the TOC pages only display high-level titles, but do not show, high-level granularity? And what if this page actually contains error, has not been updated, and so on and so forth? So there are issues with precision and recall, as we might say. So there are other approaches which use machine learning techniques to detect titles and then order them hierarchically with various techniques. And a lot of the proposed approach are in general rule-based. Until quite recently, machine learning methods have been used as well as deep learning methods. And another thing worth mentioning is considering title detection as a binary classification problem where each text line is identified as a title or not a title. And then the title hierarchization has been also framed as a sequence labeling problem. There are references that will be displayed at the end of the slides. So the description of the task is basically we provide PDF documents, and the system that a participant needs to build is to extract the table of contents. So the PDF needs to be turned into text, and then that text needs to be organized, and titles needs to be extracted with their page and level of hierarchy, so we can reorganize the top. Here's an example of the kind of documents which are investment prospectuses that we've provided the participants with. As you can see, there are quite a varied number of titles or at least lines in the document that can be considered as titles. There are footer and headers that can come in and bring in noise for the algorithms. There are sections that are less interesting from an information extraction point of view, but there's a lot of background gray areas, for example, in that case. This title is also in bold weight. It has it starts with either numbers or letters, and the titles can be numbered. Sometimes they are not. They have different colors. Excuse me. And sometimes it's not obvious whether something is a title or not. So we've designed annotation guideline to annotate these titles and also to organize them hierarchically. And this is some statistics about the train set. So there were two languages tackled this year, which are the same as the ones which were tackled last year, which is French and English, with about 70 documents and with an average number of page of 28 for French data set and 91 for the English data set. In terms of the proportions of levels of depth of each title in the TOC, so we've provided these figures here in the table, and as you can see, they don't tend to go beyond level 7, following the actual guidelines that we use, and the actual highest level are also very rare. So most of the titles actually happen between level 2 and level 5, say. I think that's about it. So just a small word on the data format that was provided and that was expected from the predictions of the systems of the participants. So each title should be provided with these parameters, which was text, which was supposed to be a string, the text of the title, which was used to match against the gold set, the ID, which is representing the order of the TOC item in the TOC page, the depth of that item, and the page where it occurs. So as I said, we proposed two corpora, French and English, and this year we took last year's private dataset, so the test set from last year, which we call the private dataset, as a validation set. So we've given it out to the participants in order to give them more training data, and we annotated another 10 documents for each language, which constituted the test set. We've also revised the annotations from previous editions because of feedback that was provided last year on some mistakes, and so we believe that we've greatly improved the quality of the annotations this year. Yeah, that's it for the presentation of the task. In terms of participants, we had many teams registered. Eventually, only 6 participated and 5 submitted a paper. It's about the same kind of statistics that we get year after year. Obviously, they're not the same teams. They were different, except from one, which is the team Daniel, which also participated last year. But this year we had participants from both university and industry. So teams like ISIOP, which is greatly represented in this workshop. ISP RAS is an institute, a research institute in Moscow, KIT in Korea, and iValua, which is a company in Paris, France. Most participants participated in both in tasks in both languages. Okay, so coming to the results, in order to evaluate the results, we took the same metrics that we used last year and provide 2 rankings, one for title detection and another for TOC extraction. The title detection is basically, it's based on a fuzzy string comparison between the text provided in the predictions of the systems and the text given in the gold data set. And the TOC extraction is a harmonic mean between the index F1 score, where basically the true positives are the titles with the correct text as well as the page number. So it helps us to identify with some accuracy the location of that title. And the index level accuracy, which is the ratio between the titles with the correct page number and the correct level, divided on the titles with the correct page numbers. I think we reflected a little bit on these metrics. We would like in the future to provide more metrics. So I think our feedback, internal feedback, is a bit like what Dominique was saying. Is we would like to investigate on the evaluation metrics. I'm jumping the gun from conclusion gun. The baseline provided was roughly simple because it was based on text content extracted from PDF to HTML, which is an open source tool, GPL tool, and each text segment is assigned a ground truth label by fuzzy matching with the annotation, whether it's the title or non-title, and each text segment is then represented by 3 binary feature, whether it has bold, italic, or is all capitalized. And I think some of these features were used by participants as well, because they're quite useful and significant. And then this was fed into an SVM to train the deck titles on the above data set. As for the TOC extraction, we've simply took the most frequent hierarchical label to assign to all the deck titles. And here are the results. So the winning team is Christopher Borez, which reached 81.8 F1 score on title detection, and also won the TOC extraction subtask with 57.3 harmonic measure. We had very good scores from other participants as well, because as you can see, for example, ISP RS also had great scores. Quite high performing scores. I think so. If you compare title detection and TOC extraction, title detection is relatively easy, although it's still hard to get above a 90% score. And what we think is probably we need to perform more error analysis to increase score, and we invite you to go to the poster session this afternoon, as well as listen to the next talk, which is the talk of Christopher Boez. And obviously there might be some heterogeneity in titles that could explain those results. In terms of TOC generation, scores show that it's actually pretty hard. It might also be that the algorithm, the matching algorithm, is a bit strict, or it could be improved for a situation where, for example, if it misses one level, then the downward levels are invalidated, because we are actually comparing the values of the level, but not the actual relative values. And no model seems to perform well on this task on appearance on the proposed data. So although scores are higher than last year, which is an improvement, and the evaluation algorithm may be revised, as I was saying. There. Okay, so jumping to conclusion, we were very happy to have run this task this year. We've had as much registrant as in the second edition, and the participation rate did not increase, but we've had very high quality papers and very high quality systems and participants. One of the things obviously we should work on is try to grow the popularity of this task. 6 teams participated and 5 teams submitted a paper, and we released a new annotated corpus for TOC extraction, where the annotations are much higher quality than the previous years. I think that's all for me. Thank you for watching, and yeah, the reference, if there are any questions, I'd be very happy to answer them.
Thanks a lot. That's really interesting.
Heard me all the way. Maybe I'll stop sharing the screen.
Cool.
Back to you, Mahmoud.
Yeah, thanks a lot. That's actually really interesting. I quite like this task because this is something we're trying to do for UK annual reports. And when I saw the results of the TOC one, so the table of content, I could tell it's actually very complicated and a lot of things looks like headers. Yeah, I've got no question about that because I'm involved in this, so I can tell more about it. But I'd like to see if anyone has any questions, like suggestions or things for improvement in the future, while the second speaker prepare the slides.
Yes.
Yeah, go ahead.
Hi, this is Anubhav from EasyUp. I have a question regarding the scores. I mean, the scores that were shared are the same or something was changed? I mean, because the scores which I have for our team compared to others, it's not the same. So I wanted to know, so what changed? Sorry, yeah.
Okay, so are you talking the scores that you run locally on your machine compared?
No. So when the task was finished, we received an email with the scores in Excel sheet.
Okay. Yes.
And so I don't see the scores which were there in that Excel sheet matching the which you provided. So I'm just confused. Yeah. Because on our paper, we reported the things which were in Excel sheet, but here it's different. So I don't know which ones are correct.
I just double. So I've only provided the F1 score and the harmonic mean, right? So the results are actually public, so I'll just share them on Teams. And so
thank you.
Is that the one you're talking about? So you're
no, we didn't receive this Excel sheet.
Okay.
But thanks a lot.
Okay. Sorry. So okay. If anything's wrong, please send me an email, and I'll be very happy to provide any explanations or.
Thank you.
Go ahead. Oh, sorry. Dominic has a question, so go ahead, please.
Yeah, sorry, quick question. Do you have an insight of how specific it is to extract table of contents or titles for financial documents compared to more maybe standard PDF? How specific it is for financial documents?
So it all comes down, I think, to whether I think there are differences between French and English for financial documents because French documents tend to follow particular templates, and so you tend to find the same kind of title wording through various type of financial documents in French, which is not the case in English. And this is because they are following particular regulations, and they're supposed to, follow a particular structure. And so the same happens with scientific articles. You tend to find the same kind of wordings in particular domains, and in other domains they tend to be less systematic. And that particularly is a challenge when there is a lot of variety in the table of contents, because you can imagine you'd want to build a table of content for scientific articles, although it's not particularly maybe it wouldn't be a useful thing to do, but it would be, for example, more challenging to do this on novels or books, literature, and that was the task that was initiated by the ICDAR competitions, and the scores were quite low, and the task was quite challenging. So I don't know if there's something specific in the financial domain. It seems the financial domain is reasonably easy in some ways, and there are some challenging documents suggested where you have to design specific approaches to tackle them. I think that would be my answer.
Thank you.
Sure.
Cool. Thanks a lot. Really appreciate your time, Ismail, and
Great to be here.
organizing this. Good to see you.